Good morning, welcome to Planet Mojo. Today I'm going to show you how a shared well system works. I figured I better do this now while I have so much stuff uncovered. We have one of the laterals exposed down here. I'll go down and show you that in a minute. And we have a hydrant right here, and over in the gator I have a shutoff. That's actually a shutoff valve down there, and we're going to abandon that right where it sits. But I'll show you the other shutoff over there, then we'll head up to the wellhead and I'll explain how that works. This right here is the curb stop. I'll show you that in a little more detail after we go over the basics here. This is all stuff that I have to put in. A normal well has your well casing, it's a little bit windy here, has a well casing going down to where the water level is. In our case, the water level is 465 feet. I believe that's the number. It's right around 450, but I believe it's 465 feet. So it's way down there, and it's through solid rock. We're 400 and some feet up on a bluff right here. So our well goes way the heck down there. I don't believe this one shows it, but it has a pipe going all the way down. Oh, there's the pipe. A drop pipe. It's got the well casing. Submersible pump. I'll show you the pump in a little bit. Our neighbor had to replace his pump, and he has the old one. The old one's still working. I'll show you that pump in a little bit. But in a normal system, you have your well, which is this right here, and then you have your electrical system in your house somewhere. That powers the pump, and then there's a switch that turns the pump on and off based on how much pressure is in your tank. I'll show you that. There's a few different kinds, as are shown here, and how they work. When the pump turns on, that adds water to the tank, and that pushes the diaphragm up until you get to a certain PSI, and then it kicks off. And as you use water, that diaphragm pushes on the water, giving you water pressure in your house. This system is basically like that. I guess this is just a colored picture of this one. I just got these offline real quick. In our system, we have the wellhead like this, and then there's a 500-gallon tank right next to it, and the electrical supply is right there as well. And it's not hooked up to anyone's electric. It's a separate electrical supply, and it's billed separately. So whoever's in charge of the shared well system has to collect money from the other people. This system supplies 8 properties here. We own 6 of the properties, and there's 2 other people at the end of the road. So between the 3 households, we pay all of the bills. The last time we had to do anything on this, it was, I believe, $5,500, something like that. We replaced our pump and a bunch of pipe sections. What it was doing was, well, say this is a pipe section. The pipe is, I believe, 1.5 or 2 inches. I'll go show you some sections of that were replaced as well. But it looked a lot like this. Or it does look a lot like this, and then there was like pinholes all up and down it. So whenever it called for water, it was squirting into the casing and going back down into the well. So the pump just kept running and running and running in order to get enough water in the 400-gallon tank. And then at some point, the pump just gave out. It was too much. And I have this one to show you roughly what the tank looks like. This is a real big one, but our tanks are the same color as this, and basically the same shape. They kind of look like a propane tank, but about twice the size. So I think first we'll go up to the wellhead. The wellhead is about 500 feet that way up the hill. We'll head over there and we're going to bring a screwdriver and some screws because we have an issue with the electrical up there that I have to fix. When you own a shared well system, you have to either do the maintenance yourself or call in a plumber. And calling in a plumber is really expensive for doing something as simple as putting a couple screws in. So let's get this stuff out of here. Okay, I'm gonna go grab a driver and some screws. We'll go get that fixed. Then we'll come back and I'll explain how these works, the shutoff, and we'll grab that hydrant and I'll explain how those work. Then we'll go and check out the entire system. I'll show you how big it is and where all the laterals are and all that stuff. Should be pretty interesting. Okay, this is where the power comes in. Yeah, this would have fell real soon. I just noticed this when I cut the grass last time. So we'll open this up and throw 4 new screws in there. This is the top of the well, the wellhead. And we have 60 pounds of pressure in there. And the tank, I think the tank is actually this pipe. I believe it goes right through the tank. I couldn't tell you for sure, but I believe that's how it goes. I've only seen the tanks from the side, so I couldn't really tell you on that. And this is the main shutoff. Oh, I'll show you a shutoff key as well. You take your shutoff key, put it down in there and turn it, and that'll shut off the water for the entire system. The system starts right here, and I don't know if you can see the other end. No, it goes down over the hill. I'll show you that in a little bit, but there's 2 houses way at the end there over the top of the ridge here. So if I shut this off, all the water in the entire system goes off. But we own this property here as well, and if we shut this one off, that only controls this hydrant here, and at some point that may control the water for the hydrant and a house over here, if we ever build a house over here. All right, I uncovered a can of worms here. This is the meter for the well. That's all this is for. So I can shut off the main here. This is already shut off, but when they built this house over here, they used this for a temporary circuit. So this is the well right here. I should be able to just shut this breaker off and shut off that whole box over there, but I don't have all of the stuff I need to fix this. I'm gonna have to get these screws out of here, and you can see the bottom ones are pulling out as well. And those, where are they? They're behind all this stuff. So I'm gonna need some extensions to get at these. I'm gonna pull all that stuff out and just put these long stainless steel screws in there because the wood is kind of rotten. But I'm not going to do all that stuff today. I'm just going to put this back together, and I'm going to throw a strap around this just in case. I don't think it's going to fall apart. The screws really aren't holding it at all. It's being held by all this conduit right here. But anyways, I'm going to put all this stuff back in here, throw a strap around this, and then I'll continue to show you how our shared well system works. Okay, I have this fixed plenty good until I can get the extensions and everything together. So the system starts at its own meter right there, and that runs to the well control or the pump control right here. And then that goes into the ground and up into here. I believe this is just a relay right here, or it's a pressure switch. That's what it is. It's a pressure switch. that tells how much pressure is in the tank here. We have 65 pounds right now, and then it goes from the tank to this curb stop right here, and it's currently on. And then this runs right in line with that next one. It's actually in here a little bit, and then it goes down to our house, then across the street, and then it goes all the way down to the bottom to a house down there, curves around, goes back uphill, and ends on one of our other properties down there. Let me show you all that. I do have video of me putting in this curb stop right here, curb stop over there by the tiny house there, and the curb stop down by the horse's dry lot down at the bottom. I believe that's either one or two videos. I did that, oh, maybe 4 years ago. I'll put a link to all the different well videos on here. We also have a video on when they fix this. They open the top and there's a rope that goes down all the way down to the pump, but I believe they just pull it up right by the pipe, take a piece of pipe off, pull it up again. But like I said, this is 465 feet down, so it takes a lot of work. They have a crane on a truck and all that stuff. You'll be able to see all that stuff on the other video that I link below. But this is where it all starts. I'll show you the next junction, which is by the house there. I did a lot of work there too. I'll show you all that, and at some point along the way I'll show you how these work and the hydrants. Okay, the wellhead is probably 20 feet above us up on top of the hill there, and the water line comes right through here and into this area somewhere, and then it tees off and goes to our shutoff right here. And I'll show you what those laterals look like down in the trench over there in just a bit. But I teed off of that, and I believe I did it over here before the shutoff here. So I'm tapped into the main line here, and I put this hydrant in there, and then a shutoff for the wood shop there. I have another hydrant inside the wood shop, and that's for all the water in there. Let me show you that real quick, and then we'll continue following this water line, and then we'll wrap up with all of this stuff. Yeah, this was an old curb stop, the one that was on here, and you can see it got bent. We'll get into that a little bit later. All right, here is the hydrant inside the shop, and it's turned on right now. We have a water line running to the other side that goes outside, and we're going to have a sink and all that stuff in here, but that's not important. Let's get back to the well system. Oh, and we also have a line coming out here and going to a hose bib right there. Okay, so there's the two curb stops over there and the hydrant, and there was a curb stop and a hydrant here. Those are the two I'm going to show you. This is the curb stop right here. We'll pull that out of there. And the hydrant is in the back of the gator. We found something out very interesting when we dug out this curb stop. This was the first time that I've seen one of these exposed. And we found out that the pipe leading to it is metal, and it appears to be copper. It's got that green patina on it. So I'm guessing this is Schedule 80 copper, and that the rest of the lines are Schedule 80 copper as well, which is very interesting. We thought it was going to be plastic like this, but if it's copper like this lateral is, we can apply electricity to it at the end up there, and we can trace this with one of those ground sensors, which is pretty cool. This is shut off right now. This valve has been stuck for years because it got hit. It was in the middle of a driveway up there, and it got hit, and that bent the tube that comes down here. And like I said, it didn't work for years. And when we dug this out, he broke the pipe. I'll show you a video of that in a second. He broke the pipe over here, and this trench started filling up with water, and I went up to the main shutoff, shut it off, and then he dipped his bucket in here and got some of the water out, and he was able to take a wrench to this and shut it off. The problem was the bent pipe. That's why we couldn't shut this off all that time. I did a lot of work here a couple years ago, but I can't remember if I don't think I had access to this. I know I didn't see that this was copper here, but what I did was replace the hydrant. This just went over to the hydrant, which was right there. And now we're gonna replace this whole thing. We'll take this piece of pipe off. It's gonna go around the corner to a new shutoff, a different kind of one, and I'll explain that in a little bit. Then it'll go up into the tiny house. The reason I have a hydrant in the wood shop there is so that I can shut the wood shop down in the winter if I want to and not heat it. All I got to do is close that hydrant and it'll all drain out into the drain, and I can have that place as cold as I want. So, like I said, the main line comes over to here somewhere. It zigzags across the street, and then there's a lateral over to here. And then from right here, it goes right down where I have mowed down there, all the way down to the house at the end of the road. There's no lateral on a property that's in between there. I don't know why they never put one in there, but several of these properties don't have laterals. But we own them all now. We own these next two properties, and this is the only lateral on those two properties. Okay, that line goes up to here, and then a lateral goes to that house there. Then it comes through here somewhere, and then goes back up the road there and ends at our property right there, right by that container. I'll show you that in just a second. But it also goes down to this property right here. And I believe you can see their hydrant right there. Maybe not on camera. They have a hose connected to it. And then, like I said, there's one last... All right, camera keeps shutting off from the heat. I had to go in the house and cool it down, but I was right there when it shut off. That is the last house on the line. It's possible that there's going to be a house here as well, and the water line ends right here. This is the 8th property that this well services. We have a shutoff and the hydrant, and the water line runs up to right there somewhere, and then over to this. There's another property, our original property that the house is on. There's actually a property right here as well. They're long and skinny. That one does not have a water line run to it. It would have to connect across the street or something like that. If there was a house there. There's not going to be a house there. All right, let's get back up there, and I'll grab the hydrant, and we'll talk about this in the hydrant, and then we'll go take a look at the pump. Okay, I brought all this stuff over here so we could work in the shade. It's like 95 degrees right now. Let me take this stuff off. I'll tell you what this is for as soon as I get it off, but let's get it off so we can see what's underneath there. That first layer that I just took off, that covered a bucket that was in the ground. The bucket, it's a bucket upside down, and the bucket is filled with gravel, and this goes down into it. This right here, this is wrapped around a few times, and it's zip tied on there. Let's get the zip ties, and I'll show you why this is on there. So this is the little drain hole, and what this does is when you lift up the valve or the plunger right here goes up and closes up this little hole here. Doesn't allow any water through it, but the water can come through the pipe and all the way up and out the end over there. Then when you put it down like it is right now, it closes off the water, so no more water can come through. It stops it right here, but that opens up the little drain, and all of the water in the pipe drains out so it doesn't freeze above ground like it is. This is buried up to right about here, and all of this is above ground. So you can use this, fill a tank up or whatever you got to do, but in the winter you have to close it after you're done. In the summertime or any other time when it's not freezing, you can leave that valve open and have like a hose on this and use the hose all summer. I have a couple videos on hydrants. I've replaced every one here, moved them around, did a bunch of stuff with them. So, oh, actually, I can show you real quick. I have the box this came in, and there's a diagram on that. I saved this box when I put in the last hydrant, but you could see there's the hydrant, ground level, and how deep you have to bury it. In our case, it's 6 feet. And then there's the drain port. There's that plug or plunger. The plunger, when it's down, it covers up this port right here. And when it's up, the water goes around it right here, and it plugs up that drain port right there. Pretty slick, hey? Okay, now for the hydrant. This is the hydrant that was over by the tiny house that got damaged. Show you the damage here. This is the riser pipe, and then it has a rod in it that controls the valve. I'll show you all that stuff, but you could see the bend in here. So the rod was bent as well, just a bit, and there was no way that it could turn. It was locked in there rock solid. So I had to get a shorter pipe anyways. This is a 5-foot pipe. This is a 6-foot pipe. I'm going to be doing a shallow installation, and one of the videos shows a shallow installation over here. So if you want to see that, make sure you check out those videos. But this is the rod. This runs up inside of the pipe and stops right there. And then the key, you stick the key down inside there, and that just catches the end of the rod there, and then you turn it, and that turns your valve, which sits right in here. This keeps it from turning, keeps the valve from turning. Let me put this all together and show you exactly how it works. So the key goes on the end of that, goes down through the top, and then you put a cotter pin on this, and see the cotter pin would go right through there, and then that sits like that, and then you have a water line on either side of that. The valve that is over there does not have a drain. This has a drain just like the hydrant there. Most of them don't have a drain like this. What this is for is if you have a seasonal home or a cottage or something like that, you can shut off the water outside, and if you have the water system designed correctly, all of the water will drain out through this hole underground, and you won't have anything above ground to freeze, except in your toilet and stuff. You would still have to do some winterizing, but you can shut the place down and not worry about draining all the pipes. It'll just do it automatically. So when I install this, I'm going to have to wrap it with landscape fabric, just like I did for the hydrant, and I'll probably just put like a bag of stone around it. And what the stone does is allows it a place to drain. Otherwise, the area might get packed up with little stones or clay fines or whatever, and that can interfere with either the drain of this or interfere with the valve itself. The valve is just kind of open to the elements there, and if you get little stones going in there and they interfere with the valve, then you got a big problem. It's a big deal to dig these things up. I should show this right away as well. This is what we got when we moved here. The plumber must have made up a bunch of these. It's just a couple pieces of welded rebar and some bar stock on the end with a slot in it, and it worked just fine. It was missing one time and we bought another one. This is what the professionals use, and it has a wrench. I believe these are for city water where they're embedded in a sidewalk. This is for the nut that's on those, and this little thing right here, if this is stuck, that fits in there and you can crank it open with that. So this is just a Cadillac version of this. Okay, we have to look at the downpipes and the pump, and then I'll wrap this up. Our neighbor's well had some issues. I believe it was late last year, and they had to pull out the pump and any of the rotten sections of pipe. This is the pipe right here. It looks like 1.25 inches, and they replace it with, I believe it's Schedule 80 plastic so that you don't have this problem, but the fittings are all stainless steel. And these sections are 20 feet long, so we got 20, 40, 60, 80. They replaced 100 feet of the pipe. So that's the pipe. The pump was laying here too. That's in his container now, but we'll go down and look at it. And you can see that pretty much the same as ours. There's the wellhead. That's the main shutoff. This is the shutoff for this property over here. That is the shutoff just for that hydrant there. This is another property over here. And then they have a couple shutoffs over there, kind of like our place. Got one shutoff for their shed and one shutoff for their house. But this is basically the same as ours. And their pressure is only at 30. Wow, ours was at 65. Oh, and their cover's off as well. Interesting. I know they're doing some work here. Some people just bought this property and they're running electric and stuff like that, so maybe that's what was going on. So altogether, this subdivision is 120 acres and it has 4 wells. Like I said, our well services 8 properties. This one services 5 and the other 2 service the rest. None of them are really servicing all the properties that they could, because a lot of people bought 2 properties or sometimes more. We bought, I believe, 6. Yeah, we have 6 properties and these people have 3. So it's way overbuilt for the amount that it serves, but nothing wrong with that. Yeah, he had the whole side of the hill dug out when he was connecting some stuff up, the contractor, and I could see the tank right below the pipe there. The tank is right there. And it was a pretty big tank, but like I said, it's only 500 gallons, which isn't really all that much. All right, let's go take a look at the pump and we'll wrap this up. I'll show you back down in the ditch again and what's going on there. So there it is. The pipe screws in right there, and then all of these wires get taped together, and those go all the way up and to the control panel you've seen at the top. Half of this is motor and the other half of it is pump. Let's see what it says. System Solutions. And we'll see if we can find out what kind of pump it is. Oh, that's kind of ground up. Too bad. But anyways, this costs, what the heck was it? It's thousands of dollars. Yeah, I don't see any identifying marks, but they didn't replace these with the exact same pump. They put a much nicer looking pump in that was manufactured in Germany. Really well made, but I can't remember the manufacturer right now. So this is not the exact pump that they replaced. Ours is replaced as well as theirs, and they put the same new pump in both of them. Pretty slick, eh? All right, let's go wrap this up, and I'll tell you what we're going to be doing next with the water. So the next thing we're going to be doing is taking this pipe right here and hooking it up to the end of that valve that I showed you way back in the beginning. And like I said, once we get all our connections in, we're going to open this up, and if we don't have any leaks, this is just getting abandoned. Give you a better view of what we're doing. You could see at this end, this is the top of a big rock here. It's probably, I don't know, based on all the other ones around here, it's probably 10 feet wide and 6 feet that way, and that's on top of another rock here. My daughter and her boyfriend put dirt from here into here and kind of ramped over the edges of them, but it went down just like a waterfall, or like steps. And they also put some dirt in here to ramp it down to this level. You could see how much gravel has been added to this. So originally, that curb stop right there was 6 feet under the ground. Now it's closer to 8 feet or even 9 feet under this area right here. So this area here doesn't need any help, but once you get to about right here, we have a 6-foot frost level, and it would be above that frost level, so we have to put styrofoam over all of the rest of this, all the way up to where it comes up into the tiny house. And then where it comes up into the tiny house, it's going to come up in a tube, and that tube is going to be insulated around the outside of it. It's going to be pretty interesting. You'll have to watch to see that. The shutoff is going to be right here somewhere, and then the tube is going to go over to here, and then it's going to have an elbow, and it's going to come straight up, and this will be the kitchen area of the tiny house. So I'll be filming that video tomorrow, and then we'll be putting it out, and it should be available real soon. So if you want to see that, make sure you subscribe and click on the update icon. If you have any questions or comments, make sure you put them in the comment section below. And if you share the video and or give it a like, it helps the channel out greatly. Thanks for watching, and have a great day.